Good morning. Can you guys hear me?
Yes, doctor.
Can see the screen?
Yes, doctor.
Okay. Sorry for the delay. There's some technical glitch. Just rectify it. Let us start the class without further delay. Today we're going to go on with chapter 4, a small chapter. And most probably I will go for chapter 5, maybe later in the tutorial. Alright. What is chapter 4? It is a continuation from for the first of all, good morning. Hope you guys are in good health and are doing your assignment. If you guys still have any problem in accessing the link, please let me know. I will rectify it for you. Alright, chapter 4. Chapter 4 is basically a continuation from chapter 3, especially from normal distribution. So we are still in normal distribution. Alright. Later I show you the connection between 1, 2, 3 and 4 later in the tutorial. Now let us start the exercise. Alright. If you look at this example, the first example, the first example in normal distribution, the previous one, we don't have any sample size. We don't simply pick any sample. If you read this example, a production line makes units which are normally distributed with a mean weight is a weight, x is weight, and it is normally distributed with mean 200 and standard deviation is 9. We write in terms of variation. Now in this question they are asking what is the probability of a sample, what is the probability of a sample of 36 units having a mean weight of 233 gram. Now let's say the only difference between the previous normal distribution exercise with the chapter 4 is this one. Is this one. A sample is given. Now let me recall back what we have done in third chapter. Let's say weight is here and the mean is here. This is your mean and this is your standard deviation in variance term. If it is a normal distribution, chapter 3, the question would be what is the probability that the mean weight is the question. Okay, if we want to convert that to a chapter 3 question, the question simply would be what is the probability what is the probability that a mean weight is more than mean weight is more than 200 gram or more. Okay, there's no sample size. That's what we did in the chapter 3. Okay, we did the probability, for example, like this. So if this is the question, what is the probability? Mean weight is 203 gram or more. So normally what we do in the normal probability, we will write this. Okay, I'm not doing chapter 4 now. I'm doing chapter 3. I just convert the question according to chapter 3, so that you can see the difference in chapter 4, what is going on. This is what we did in chapter 3. Okay, minus mean divided by standard deviation, you will get, and of course you will draw the diagram all, and your probability should be 37. This is what you did in chapter 3, normal distribution. Okay, normal distribution. Now the only difference from chapter 3 and chapter 4, the one we are going to do now, the only difference is that in chapter 4 they give you a sample size. Okay, they said the same thing, the mean weight is 200 gram, the standard deviation is 9, but they are not considering all the units are there. They just pick certain sample and then from that certain sample we need to conclude that what is the probability the mean weight is more than 203 gram. So this is based on certain sample. Remember, the chapter 3 is for all the units, chapter 4 is not for all the units, it is only for certain sample. That is the reason the chapter is known as sampling distribution. Okay, sampling, you can consider as a sampling. In this case you can consider a sampling normal distribution. Okay, all the samples we will regard as a sampling normal distribution. Okay, so let us do the example 1. This is not example 1 yet. This is not example 1 yet. Let me erase this. This is still chapter 3, normal distribution. Now let us do the proper answer. What is this answer? So if there's a given, if sample is given, then how are we going to handle this? What is the probability normally we will write x, isn't it? So if there's the sample is given, you put a bar here. Okay, now the x bar is known as sample of the units. What is the probability? The sample of 36 units having a mean weight of, okay, if it is a face-to-face class, I would explain in further certain things here. Since it is online, I choose to omit all that information. Normally we minus the mean, isn't it? This one also same, minus mean. But then in the chapter 3 we only divide by standard deviation, but here is a little bit different. This is the formula. Okay, we divide by standard deviation, but it is also divided by the root of sample. Okay. This is the formula, minus the mean and divide by sigma over root of n. The sample size is consider in the calculation. In the normal distribution, chapter 3, no. Okay, you cannot see sample size. If you do this, and your answer is this one. When we consider sample, okay, we when consider sample, try to use this method. We are not inserting, we are not writing like this. We are not writing like this because this means each and every unit in the population. Now we are not dealing with each and every unit, we are dealing with the mean weight of the 36 sample. Okay, the mean weight. So the question is, remember the question is, what is the probability of sample 36 unit having a mean weight? Okay, so another highlight. One is sample size, another one is they are asking for mean weight. Remember mean weight, the notation for mean for sample is actually x bar. That's why I'm using x bar here. Anyway, if certain things I cannot explain in online and not enough time for that. If you see this kind of question, then you use this kind of notation and this kind of method.
Sir, I have a question, sir.
Yeah. What is that?
Sir, the P bracket Z or 7 greater than 200 minus 203 minus 200, right? That is 7.
Oh. My EZ is look like this. I am very, very sorry for my bad handwriting. We'll improve as soon as possible.
Thank you, sir.
Okay, let us move on to next question. Try to read this. It is thought that the annual cost of transport to and from work for employees of a company is normally distributed with mean 100 and standard deviation 10. What is the probability that a sample of 100 employees will be sample is given here, sample mean is given here, and for sure this is sampling distribution. That's how you identify a question. So the formula is you have to use this formula. The bracket should be like this. Okay, the bracket should be like this, but in this case I allow you to do this. Okay, only in my class, no problem. I suppose you guys know how to use the normal table, Z table, so I no need to draw again the graphs, bell shape graph, all these things you should know. Okay, I have done A. Can you guys try for B before I give you the answer? Try for B. for B. Did you guys get 0.0? Okay, let me do this anyway. So this one, in case if you guys forgot, 3 here, the shaded part is here. From the table here, from the Z table, you can see three. This is the value, so you can write here 0.00135. Okay. You can round off here. I round off 228 supposed to be 2275. I just round off, put it 228. You can also write 2275 for the question A, because previously I was using different table. Now I'm using the PPA table. So don't worry, you can round off and you can still give the answer. Can I move on to next part? Have you done? Can you get the answer?
Yeah, already done, Doctor. Okay. You can move on.
Right. Anybody has chat? Okay, let us move on to next question. But before we move on to next question, there is one information I need to explain here to you. It is known as central limit theorem. In the previous question, you can see the word normally distributed. Okay, it is clearly tells you that the question is a normal question, so you have to use a normal table. Later on, maybe in the tutorial later, I will introduce to you to another 2 more table T table and F table. Okay, the one we are using for normal is a Z table. Okay, so basically altogether 3 tables you will learn. So far we are using Z table. Later on I will introduce to you 2 more table, T table and F table. Now if you see normally distributed, then you use Z table. If the question tells you, again here, where is the word? Normally distributed. It is clearly mentioned to you that the question is normal distribution, therefore you use Z table. Now, in the example below here, the output of glass panel has a mean thickness of 4 cm, a standard deviation of 1 cm. If a random sample of 100 glass panel is taken, what is the probability of the sample mean having thickness between 3.9 and 4.2? Here we can see sample of 100 and sample mean. These are 2 keywords for us to use this formula. This one, the key. But then another thing you need to notice here, does the question tells anything regarding normality? There's no normal term here. So there's a question mark now whether you can use normal table or some other table, Z table or some other table. We don't know that. Therefore, here comes the information. It is known as central limit theorem. What the theorem tells: if the sampling is random and sample size is sufficiently large, okay, sufficiently large means if your sample, the one you pick, the picking sample, the one you choose for your experiment, is more or equal, if more or equal than 32. Okay, people have done some experiment. Some will tell 30, some will mention 32. Let us take the 32 for this syllabus. If your sample is more than or equal to 32, it is by default automatically it is a normal distribution, even though they never mention. Even though they never mention any word here normal distribution, you look at the sample now. This is 100. 100 is more or equal to 32. Therefore, this is a normal. Okay, so you can use Z table, normal. So let us do this. X is thickness, mean is 4, standard deviation is 1. Okay, find the probability that sample mean X bar So in normal distribution, you can put like this. You can also put like this. Okay, if without, it can be without. There's the equal don't have effect on the continuous distribution. I have mentioned this earlier. If you put like this, it is not wrong, still acceptable. You can put the bracket. You would want to put the bracket, it's up to you. It's just I feel it's too messy, too much of bracket. As long as you understand, I understand. Okay, so you will end up here. Can you get me the answer? So some of you have done this, yeah, good. Some of you are trying. 0.00135, yeah. Compute this for me. Try. By this time you should be able. You are an expert on using the Z table. Please do all the past year papers and send to me the answers. So far we have covered question 1 and 3. The one we are doing now, I guess, question 2. So after this class, after today, you can start do the question 2 in past year papers. Not question 2 anyway, not exactly question 2 in past year papers. You have to search for it, which topic, which question covers. So we want this one. We want this answer. What is this one? 1 minus, remember this one? 1 minus A and B. So if you look at the table, your A would be 0.1587. Your B would be 0. 2275. So basically the region we are going to find is some of you get this. So the region going to find is 1 minus 0.1587 minus 0.02275. If you do this, you will get 0.81855, or you can write it 8186 also acceptable. So many of you, I see you guys get this. Yeah, good. 819 also acceptable. All right, some of you are doing good. Those who cannot do can copy this first. Those who have done, please try exercise in class 2. it is normally distributed, even though they never mention here. But the sample size, you can notice that the sample size is greater over 32, therefore normal distribution. So I get this 0.75. Yeah, some of you get 2266. That is answer. Very good. Hope you guys get this answer. 266 for A. Any one of you? Yes, good. So this is A, the B is okay. So you guys get 1.5. 1.5 here is, you can see here 0.06 68. I think Kausalya is a typo, I guess. I think you get 0.0668 just when you type, it becomes when you mistype the thing. Yeah? That is good. We have done B. Nurul Najiha also have done B. Christopher has done B. Now let us look at C now. For C, I need to go to next page. Eh? Three, 3, 4, 2. Let's get this. Yeah, good. 0.81855, that is your C. Good. So that is your, this is the answer for A. Answer for B. And answer for C. If you have done this, get the answer, that is very good. Your final answer is final question, something like this. Now the next part is sampling distribution. I suppose you guys have done this the previous one. So we are moving to the next part now. Sampling distribution of the difference between two means. Okay, if I show you the formula, it might be, I am not interested in showing you the formula. Let us do an example. Going for next page. I think example 3, 2, 1. Yeah, example 3. If you are given two sample, okay, suppose that the starting salaries of MBA at WLU are normally distributed with a mean, all right, and then there's another sample, there's another portion, there's another section, another group starting salary of MBA of UW. So first they have given you this, and second group is UWO, University of Western Ontario. Normally distributed. This is your mean, standard deviation, mean and standard deviation. All information are given there. Let us put it on table. Mean, standard deviation, sample size. The mean for W, normally when this type of two sample type question is given, you do a table like this and try to identify all the information. For WLU, the mean is 62. Standard deviation is if a random sample of WLU 50 and random sample of UWO 60 are selected, what is the probability that the sample mean starting salary of WLU exceed? They are asking, they have given you two group and they have given you the mean, standard deviation and sample size, the size they have chosen to do this experiment. They are asking you what is the probability that WLU, the mean salary, the mean starting salary of WLU is exceeds greater than WO. So we're going to find out how much, what is the chances in this, whatever information we have here, what are the chances for this WLU people having a greater salary than UWO? How much? What is the chances? What is the probability? So let us do this. It's almost the same, the previous one, single sample. Now we are doing two sample. The previous one, single sample. So here I will put X bar 1 indicating WLU, X bar 2 indicating UWO. Sorry, too much of W and U, WW, confusion. X1 greater than X2. What is the probability? If I rewrite this, I can rewrite this like this. And what you do, the formula for this thing will become Z. Right here. 1 minus, look at the formula here now. I instead of showing the formula, let me do this. Normally you minus the mean, isn't it? Yeah, here also you will do something like that, but in bracket write the x1 mean first minus the x2 mean, divide. In normal case, what you do, sigma over n. This is the single sample. For double sample, you do the same thing, but like this. What is the standard deviation for the first one? And sample size would be 50 plus $60. There's a square there, remember. Now you can compare this with the formula here. Okay. Now once you get z is greater than negative 0.64, you do the normal okay. So I suppose you guys know how to do this. Okay, this is the answer. Okay, those who have done this, okay, so the probability that the WLU is greater than WUWO, that's another part, university, is 0.73. Those who have done this, try exercise in class 3. Last exercise for today. Later I'll see you guys at 11 and 2.